On part 2, for logarithms, we will study types of logarithms and properties of logarithms. Now we have two types of logarithms that are the main types which are widely used. First one is common logarithm. The common logarithm is just a logarithm with base 10. Means that when we see a logarithm written just log x, means that this is a logarithm with a base 10. And that's something we need to understand, that without writing a base, so the base is 10, and this is the most widely used generally in physics and chemistry, in biology and different sciences. For example, when we have logarithm 8 to the base 10, we just write it logarithm 8. Also, logarithm 10 to the base 10, which equals just logarithm 10, and you know that when these two values are equal, then the value of the logarithm is 1. This is for the common type. Another one important type, which is famous also, is the natural logarithm. This is a logarithm with the base e. E is just equal to 2.7128 and other values, which is a famous irrational number. So this number has no end. That's why we write it in this type. The natural logarithm is logarithm with base e, and it is written as ln x. So when we see ln x, so we have a logarithm, and the base of this logarithm is e. Well, so this classification in first type and second type is adopted on the base of the logarithm. If it is 10, we don't write the 10, and it is written as common or known as the common logarithm. The second one is written as ln, and we don't write the base, but we know directly that the value of the base is the exponential function, the famous irrational number. Properties of logarithms. First property saying that if I have the argument and the base, if both are equal, then directly the value of the logarithm is 1. So this is happening if and only if the argument and the base are equal. And in this case, we write it as logarithm a to the base a equals 1. For example, if we have logarithm 3 to the base 3, it equals 1. And if we have logarithm 10 to base 10, which is not written, so if I see just logarithm 10, I know that my base is 10 and the value is 1. Also logarithm, the natural type, logarithm e or ln e, to the not written base, it means that it is e. So argument and base are equal, so the value is 1. This is property 1. Property 2 saying that the value of logarithm of 1 is 0, whatever the base is. So if I have logarithm 1 to base 5, it is 0. If I have logarithm 1 to base pi, it is 0, and any other value. If the argument is 1, the logarithm value is 0. Number 3, if I have the value of argument is 2 multiplied numbers, so I can separate the logarithm. I can make it logarithm x to the base a plus logarithm y to base a. You remember that the arguments must be positive values. So if they are multiplied together, I can separate logarithms to 2 terms with addition. This is, for example, logarithm 30. I can write 30 as 3 times 10. Remember that the base is not found. It means that it is equal to 10. Then this is a multiplication operation, so I can separate them. and make them logarithm 3 plus logarithm 10. And then the value of logarithm 10 for the unwritten base, which is 10, it equals 1 plus the other value, logarithm 3. So in general, if I have many values that are multiplied in the argument place, I can just separate them by addition for the same base A. The fourth property, if we have the argument raised to a power, so I can just turn the power and put it beside the logarithm. It's going to be, when I have logarithm x power m equals m multiplied by the logarithm for x for any base a. So for example, if we have logarithm 25 to base 5, I just write 25 as 5 power 2. And now this 2 is just the power here. So I can put it beside the logarithm. Then I will have logarithm 5 to the base 5 multiplied by 2. And just from first property, if I have the argument and the base are equal, so the value of the logarithm equals 1. And then 2 times 1 is 2. Now, what if the argument is as a fraction and the value of the power is in the denominator? This is not something complicated. It is not difficult. I just switch the value and put x power n in the numerator. So it's going to be x power negative n. And directly I can just put negative n beside the logarithm. And then it's going to be negative n multiplied by logarithm x to the power to the base a. So this is a case of argument written at the bottom. What if the argument is under a root? Just we use the definition of powers of root. So x power n under a root to power m. We write it just as x power n over m. And now this is the power of the argument. I just multiply it by the logarithm. So it's going to be n over m multiplied by logarithm x to base a. For example, you can just put easy numbers just like x power 1 under square root and solve it. Well, the last property, number 5, this property is saying that if the argument is a fraction, so means that x divided by y. So the relation now between the two numbers is an operation that is called division. So if they are divided, we separate them by subtraction. And we say logarithm x to the base a minus logarithm y to the base a. For example, if I have logarithm 0.12 to the base 5, I can write 12 just a fraction, just like x over y. It is 12 over 100. And of course, we will simplify them, dividing by 4. So 12 divided by 4 is 3, 100 is 25. And now this is logarithm 3 to the base 5 minus logarithm 25 to the base 5. And I'm sure that I can write 25 as 5 power 2, just like this solution here. And then the 2 will be multiplied here. So this is 1 times 2. And this is going to stay logarithm 3 to the base 5.